Hello everyone. So we are here to discuss the chapter called as ratio, rate and proportion. In this, we have the first topic which is ratio. The second is rate, which is just an extension of ratio. And the last topic is proportion. We have a list of important things to deal with in this chapter. And I will go here and tell you. We'll start with working with ratio. We'll understand what is ratio. Once we understand what is ratio, we'll see how we can use it, how we can work around with it. Then we'll see the ratio and the scales on the map. And then we'll see the actual topic called as rates. And after we know the rates, there will be graphs and then there will be proportion. This is a fairly longest chapter because there will be a lot of exercises in this. But the chapter's crux is very simple and it is very easy to understand the meaning of it. So without wasting any time, let's directly start with the first topic, that is ratio. Now supposedly I say that when I was 8 years old, my sister was 4 years old. So somebody will say the difference between our age is 4 years, which is right. Today I am 46 years old and my sister is 42 years old. The difference is still 4. It is obvious because once she was born, the age gap was established. Each year, my age will grow by 1 year and her age will also grow by 1 year. So that's not changing at all. The difference will remain the same. But in this case, in the first case, my age was double as compared to my sister. And in this case, it is not double. In fact, this time, if we have to compare the ages, then we will say that the ratio of ages is 46 upon 42, which is equal to, we can divide by 2, we get 23 by 21. This is the meaning of the word ratio. When we take the ratio of two things, or sometimes three things, four things, but the ratio essentially means that you are trying to divide the given numbers by a common factor and then you reach a simple fraction, simple ratio, and that is how we evaluate. The difference of ages would be absolutely the difference, the comparison of ages. We say I am older than this, she is older than me, she is younger than me. This comparison is based on the difference, that is based on subtraction, but the ratio is based on division of the numbers. So if we see that something is double than something, it is sometimes, it is always like that. For example, if you take a rectangle, or if you take a square, in this square, if the side of the square is A, then this side will also be A, this side will also be A, this side will also be A. So the square side is A, and the perimeter of the square, the perimeter is sum of all the sides, is always 4A. So the ratio of side of the square and the perimeter, this ratio will always be A upon 4A, which is equal to 1 upon 4. What we are doing here is, we are not trying to compare or we are not trying to check which is greater, which is smaller by subtraction, but we are saying that we will divide them and we will find the ratio. When we find the ratio, it is based on division. We are trying to say that something is so many times bigger than something else. So we are talking about the multiplication factor. Like we will say the perimeter is always 4 times the side. So 4 into side. How do you know this? How do we get this? We get this because the perimeter divided by the side of the square is equal to 4 upon 1. This 4 upon 1 has come as the ratio of perimeter is to side. The ratio of two quantities, suppose the quantities are x and y, then the ratio of x and y is written as x is to y. We can also write this as x upon y, but it is more frequently written as x is to y. The reason of this is very simple. Supposedly we are taking the ratio of three things. For example, three students or three friends wanted to start a small shop, and they decided that they will invest money in the shop. The first friend said, I will put some money. The second will say, whatever you put, I will put double of this. The third friend said, whatever the first one put, I will put three times of it. So the investments are, supposing the first friend invested X rupees, the second will invest double, that is 2x, and the third will invest 3x. So their investments are in the ratio 1 is to 2 is to 3. The meaning of the ratio, the word ratio is take the division, just divide by the common factor, whatever is the common factor, just divide and write in this form. Now if we were to write it like this, then we do not know how to write 1 upon 2 upon 3, how do we interpret this? Hence this is not preferred. That is why this method is preferred. But if you are talking about the ratio of only two quantities, this is also fine, this will also work. Now let's just see some problems based on this, and we'll see how we can work with the ratio. So we'll see the first topic is working with the ratio. Well, the ratio. Please go on. Yeah, okay. Ratios are expressed in the simplest form when we write the ratios. Supposedly the ratio is 20 is to 100. Supposedly there is a rectangle, and in the rectangle the length is 100, the breadth is 20, and we are taking the ratio breadth upon length, or we can write this as V is to L is equal to 20 upon 100 or 20 is to 100. Then we just divide by the common factor and we get this as 1 is to 5. The idea of ratio is to say that some quantity is equal to this x number of times, y number of times, 5 times, 3 times bigger than the other quantity. Then in this case, the length is 5 times the breadth. The ratio will tell us what is how many times the other quantity. So this is what we use the ratio for. Now let's see some examples. Please go down. We'll see directly start with the exercise. Exercise 21.2. Yeah. Write each of the following as a ratio. 9 children is to 9 adults. Now we are not comparing the adult with children. We are comparing the numbers. The numbers are 9 is to 9. That is equal to 1 is to 1. Because there is no definition of what is children. If we were to compare their ages, then we must know the age of each child and the age of each adult. We don't have any clue from the given example. So we just compare the numbers. The numbers are 9 and 9. That's it. Next is 1 liter to 5 liters. That is very easy again. 1 liter is to 5 liters. 1 is to 5. 25 minutes to 3 minutes. 25 minutes is to 3 minutes. There is no division possible. So this is the ratio. 25 is to 3. 18 seconds to 1 minute. Now this is very interesting. 18 seconds is to 1 minute. That is 18 seconds is to, because the units are different, it is not right that we just simply go with division. First make the units equal. If you have to convert one unit so that the second unit is equated, convert this minute into seconds. Sometimes it is given that this side will be hours and this side will be minutes. You can choose to keep both the units as minutes. Whatever is a comfortable, convenient unit, make both the quantities into that unit. So we will write 18 seconds is to 60 seconds. Now both the quantities are divisible by 6. So we will write 3 is to 10. So the answer for this is 3 is to 10. 50 cents is to $1. 15 cents is to $1. that is 15 cents, is to 100 cents. $1 is equal to 100 cents. These are called as cents. The dollar is converted into smaller unit, that is called as cents. It is being given the name cent only because CENT, cent, actually stands for century. And century means 100. The meaning of the word CENT itself, cent itself means 100. So this is 100 cents. We use the word percent, PERCENT, that is per 100. That is what we are doing here, because cent is, we are not converting it to percentage, but because I am saying that the meaning of the word cent itself is 100. So 15 is to 100, and now we divide by 5, so we get 3 is to 20. And that's the answer. That is how we can solve all these problems. We'll just go on. I'm not solving these problems for you. I want you to solve these problems. Question number 2, question number 3, they are all very simple. Question number 4, check the entire first exercise. That should not be a difficult exercise for you at all. And then we'll just go on. Now please come on. So our first exercise is finished here. Then we'll talk about equivalent ratio. Now it is very important we understand this word first. Before I explain what is the meaning of equivalent ratio, I would like to explain the meaning of the term equivalent, and then we'll talk about equivalent ratio. The word valent, VALENT, this word comes from the word VALUE, value. If what is value is given by the term valent, you see this in chemistry as well. There was a concept called as valency. So if valency of one element is 4, that means the value of how many reactive bonds can be formed, how many electrons can either be given or taken. The value of number of sharing or the number of bonds was valency or valent. The meaning of the word valent is giving the value. Equivalent is having equal values. My mom, whenever I go back home, whenever she is preparing dinner, she would just call me. I am sitting in my room, she calls me and she asks me, how many? She is not asking anything, she is saying how many? And I tell her 3 or I tell her 2. So she understands that I am so hungry, or I am hungry enough to eat only 2 chapatis on that day. So she will make 2 chapatis for me for that meal. That is according to her, in that situation, as per her, the value of me for making dinner is 2. She is not putting my value, but for the purpose of making dinner, she is saying that my son equal to 2. Why? Because my value is for that. Therefore, I will be equal. If the ratios are equivalent, then their values are going to be equivalent ratios. Are when the 2 ratios are called as equivalent. If the values of the 2 ratios are equal. And how can that be? So supposedly somebody is saying that my age is 10 and somebody else's age is 20. Not my age, somebody's age is 10 and his other friends or his older cousin's age is 20. And then we say the length of a rectangle and breadth of a rectangle, length of a rectangle. So here the ratio, if you make the simplest ratio out of this, it is 1/2. If you make the simplest ratio out of this, it is 1/2. So these 2 ratios are equivalent ratios. If the values, after dividing, if you get the same value by dividing the common factor, you get the simple ratio. and you convert it into simple fraction by simplification, then the simplest form that you get, if both have equal simplest form, then these two ratios are called as equivalent ratios because their values are equal. They might look different, but it does not need to be different. For example, you might think that 1.7 and 5.8 and the other ratio is now these two may not look to be equal, but if you check this, then 1.7 upon 5.8 it is not possible to divide. But you can multiply, and you can multiply by 10, so you get 70 upon 58. And here you can divide by 2, you get 34 upon 2 is 70, and this is divided by 2, you get 58. And these two values come out to be equal. So these two are equivalent ratios. So it may not be necessary or it may not be obviously visible in the first case that the ratios are having same value. But if you carefully observe and carefully calculate, you will get if the values are equal or not. Not every ratio will have the same value, but some ratios will have the same value. If the ratios have the same value, they are called as equivalent ratios. Let's see some problems based on this. Let's see the exercise. These are simple short examples. We'll see the exercise directly. Yeah. Find the unknown value in the following equivalent ratios. Use whichever method you find easiest, and these ratios are given to be equivalent ratios, and we are asked to find out the unknown value. Let's see this. It is not difficult, but yeah, let's see. Let's solve. The first ratio is 2:3. And the second ratio is 6:x. This also means 2/3. This also means 6/x. And if these two are equal in value, they are equivalent ratios, so the values are given to be equal. It is already given, so we don't have to worry about it. If the values are equal, just cross multiply, whatever, any mathematical exercise. Just do not write anything for the sake of it. Any correct mathematical operation will give you the answer. 2 into x is equal to 3 into 6. We just cross multiply. And then we'll say x is equal to 3 into 6 is 18 and divided by 2 here and we get 9. So the value of x is 9. And if we just put it here, then 6 is to 9. Both these numbers would have been divisible by 3, and if you divide by 3 you get 2:3, which is the same on the left hand side. So they actually come out to be equivalent. This was just for checking. You don't have to solve this. Up to this point it is equivalent. Next, I don't want to solve any of this now. This is up to you. Let's see the second question. What is that? Use the equation by cross multiplying to find the unknown values in the following ratios. Okay, before we say use the equation method or the cross multiplying fraction method, so there is one more method with which the same problem could have been solved, and I think it is better that we solve it by one more method and then we move on. So it is given that 2:3 is equal to 6:x. That means 2/3 is equal to 6/x. Now we can decide the method by which we are solving. I converted it into an equation form by cross multiplying. We get an equation. This is called as an equation. What is an equation? What will have a left hand side, what will have a right hand side, and an equal to sign in between. So the two things are given to be equal. That is what we call as equation. Now we are forming an equation by cross multiplication. But here we can avoid to form an equation. We can say, what should I multiply this so that the numerator is 6? So 2 must be multiplied by 3. So I will write 2 into 3. But then it is a crime if you multiply only the numerator. You have to multiply the denominator by the same number. So even the denominator is multiplied by the same value. And there is no need to multiply on the right hand side because the right hand side has numerator equal to 6. So here this is 6 upon 9 is equal to 6 upon x. Now if you compare, the two ratios are equal. So they are equivalent ratios. And also the numerators are equal. If the ratio is equal and numerator is equal, denominator has to be equal. So we write therefore x must be equal to 9. And we get it. So this is another method of solving by adjusting either the numerator or denominator. And this is method of equation by cross multiplication that we get. Here you can given that you how to solve using cross multiplication by the method of equation. No other method will be accepted. And this is all. You can just check. There is nothing great about it. It is this method. So even the second question you can do. Question number 3. Say whether these statements are true or false. Actually, unlike Cambridge, to take a question like say whether, it should be determine whether the statements are true or false, or state if the given statements are true or false. Let's forget them for once, and then if a statement is false, explain why it is false. Okay. The ratio 1:6 is same as the ratio 6:1. See, 1:6 means that the age of the first person, if it was 10, then the age of the second one was 60. And 6:1 will be absolutely opposite. Means the age of the first one is 60 and second is 10. These two cannot be equal. Why? Because the meaning of this will completely change. The ratio 1:6 is equal to 6 upon 36, which is fine. We multiply both by 6. We can divide both by 6 and we get this. These are equivalent ratios, but 1:6 and 6:1, they are not equal. We go by fraction. So it is just the same logic. 1:6 is equal to 3:18. Now check this. If you multiply by 3, 3 into 1 is 3 and 3 into 6 is 18. So you can just reduce this fraction by dividing by 3 and you will get 1:6 again. So they are equivalent fractions. So if the answer is true, there is no problem. If you think that the statement is false, you will have to explain. Like in this case, we have to explain that the ratio 1:6 and 6:1 are not same because 1/6 is not equal to 6/1. 20:15 can be expressed as 3:4. Let's check. 20 upon 50 is equal to, both are divisible by 5. So I get this is 4 upon 3. This is not equal to 3/4. 4 upon 3 and 3/4 are not equal. And because they are not equal, the statement is not right. It is false. Again, you just carry on and help yourself. Question number 4 and come down. This question number 5. We'll solve one of them. Let's solve question number 4. Question number 5 we can solve. An alloy is a mixture of metals. Like steel is an alloy. It is a mixture of graphite, which is carbon, as well as iron. Sometimes industrial use of steel, the carbon is not used in some chemical factories. So some other material called silicon, which is also semiconductor, it is used. So that kind of steel is called a silicon steel. Why am I saying this? Because every alloy will have certain metals mixed. Most of the gold used in the jewelry is an alloy of pure gold and other metals which are added to make the gold harder. Gold is very brittle. It is very difficult to give an ornamented shape. So the gold has to be actually mixed with some other metal and then you can make an ornament out of it. So gold, as much as it is popular and people wear gold chains, they gold earrings, the rings or bracelets, kind of people who wear gold, but the gold is very difficult to be, given any kind of shape. You have to mix it with some other impurity. This is what the question is talking about. Pure gold is 24 carats. It's a unit to measure this. The quality standard is about this. What is the meaning of carat? We'll see. So 18 karat gold is an alloy of gold and other metals in the ratio 18:6. The addition of these two must be equal to 24. So 24 karat gold is 24 gold and 0 other metals. The quantity of gold is 24 gram in 24 gram of 24 karat and 0 grams of others. But if you are talking about 18 karat gold, then this will be 18 gram and this will be 6 gram of other. 18 gram of gold and 6 gram of other. If you have 16 gram of gold and then 8 gram of other metals, then this becomes a 16 karat gold. That is how the gold carat standards are defined. What we are asked is, in other words, 18 upon 24 parts of pure gold and 6 upon 24 parts of other metals. A jeweler makes 18 karat gold alloy using 3 grams of pure gold. Now see this, we have 18 karat gold. Now how will 18 karat gold be made? 18 karat gold would be made, classically it would be made by mixing 18 parts of gold and 6 parts of other metals like copper. In this case, it is given that, it is already given that 18 karat gold is made, but in less quantity. We are not making 24 grams. Supposedly this was 18 grams of gold, 6 grams of other metal. We will then form 24 gram in quantity, but the gold will be called as 18 karat because only out of 24 only 18 is gold. So if we don't want this to be in 24 gram, which is quite large quantity as far as gold is concerned, we want to do a small amount. So what you do is 3 grams of gold, 3 grams of gold. What is the mass of other metal? I call this mass as x gram. The question is, in 18 karat gold, it is already known that in 18 karat gold, the ratio is 18:6, that is 18 grams or 18 parts of gold, 6 parts of other metal. What is a part? A part can be 1 gram, half a gram, whatever it is same here. 0.1 gram, 10 grams, sometimes it is 18 into 10 gram, it is 6 into 10 gram. Whatever you multiply, the same multiplication would be happening here. So 18 parts of gold, 6 parts of other. Now this, it is given that it was because it was very small amount, only 3 grams of gold was there. And there is only 3 grams of gold. Then x grams, whatever the gram of the other metals. And they are asked to find out what will be the mass of other metals. So what is the value of x? So we will only take this ratio, 18 upon 6 is equal to 3 upon x. Both are 18 karat gold, and in given karat gold, the ratio of gold's quantity to the ratio to the other metals quantity, that ratio will remain constant. So this ratio 18 upon 6 and 3 upon x are going to be equivalent ratios. Now the rest is just divided by 6, we get 3 upon 1. So 3 upon x, x must be equal to 1. How do you cross multiply? You write 18 into x is 18 is equal to 3 into 6 is equal to 18. So 18x is equal to 18. So x is equal to 1. And 1 gram of gold. An 18 karat gold chain contains 4 gram of pure gold. Again, 18 carat, which means 18 parts of gold and 6 parts of other metal. And it is given that 18 karat gold chain contains 4 gram of pure gold. How much does the other metal it contains? For it 5 gram. Again, take ratio 18 upon 6 is equal to 4 upon 1. And you will get the value of 5. This will be in fractions. It is okay. Just take 18 upon 6 is equal to 4 upon 5. You get the answer. I think it will be 1.33 or something like that. 4 by 3 maybe. What is the ratio of gold to other metals in 14 karat gold? 14 karat gold will have 14 part of gold and 10 parts of other. So the ratio is 14 is to 10. We can divide by 2, so we get 7 is to 5. What is the ratio of gold to other metals in 9 carat? 9 carat, 9 is 2. The total has to be 24. So 9 other will be 15. 9 carat, 9 parts of gold, 15 parts of other. 9 upon 15, 3 is to 5. This is the trick. I hope you get this. I hope this helps. Please solve the exercise 1 and 2. And then, is there any other exercise come up? Dividing a quantity in the given ratio. Yeah, we will take this and the ratio and see in the next video.